Hello friends, this is the part 6 of JEE Mains 2024 PYQ of organic chemistry. So the today's first question is the product C in the given below mentioned reaction is. The given reaction is CH3 CH2 CH2 Br is reacted with KOH alcoholic KOH in presence of heat gives A, which is further reacted with hydroboromic acid, which gives B, and which one is further heated with aqueous KOH. This is the simple reaction. I hope you have already studied this reaction. What will be the product A first? If we react alkyl bromide with alcoholic KH, then what happens? Elimination reaction happens. This base takes H place from alpha hydrogen atom. This base takes alpha hydrogen. This base removes hydrogen from. This one is the alpha carbon. This one is the beta carbon. Base removes H plus from beta carbon atom, and bromine is knocked out. Then the double bond is formed. The product A will be propyne CH3CH double bond CH2. This will be the product A. And after any alkene, if reacted with halogen acid, what will be formed? Here the Markovnikov addition of H plus and Br minus occurs. So here what will be the product? What will be the product? What is the Markovnikov rule? Negative party is attached to that carbon atom which contain less number of hydrogen atoms. So Br minus will attach to that carbon atom. So here Br is attached, and here CH3. So again these two bromopropane heating with aqueous KOH. If aqueous KOH is used, then what will be the product? Here the nucleophilic substitution reaction occurs. Therefore, I am not going to discuss about SN1 and SN2. This will be SN1 reaction. First SN2 reaction. First bromine will knock out and OH minus will attack on that carbon atom. That is, this goes through SN1 SN2 mechanism. So what will be the last C product? CH3CHOH CH3. So what is the IUPAC name of that product C? Propane 2-ol. So here the option 2 is correct. In the two option, propane 2-ol is given. So second option is correct of that question. So now the next question is, in that question two statements are given. First statement is IUPAC name of the structure is given that OH CH2 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 CO CH3, that is here this one is ketone. So in the statement first, the name of IUPAC name of that compound given is 7-hydroxy heptane 2 1. And in the second statement, 2-oxoheptane 2-7-1 is the correct IUPAC name of the above compound. What is 2-oxoheptane 7 all. So first, if you know about the rules of IUPAC nomenclature, then first find out the what is the IUPAC nomenclature of that structure. So here are the two functional group. One is OH, one is keto. So among these, this functional group is principal. That is first priority we should have to give to ketone group. So numbering should be starting from that carbon. So less number should become to principal functional group. So here 1, 2, 3, 4, 5, 6, 7. So what will be the IUPAC name? First prefix is given by the prefix is of the, so by naming the nomenclature of compound, the functional group which has lowest priority is written as prefix, that is 7 hydroxy 7 hydroxy. Then the functional group which has the highest preference is or priority is written as suffix. So first 7 carbons are there, therefore heptane heptane 2 1. So what should be the IUPAC name of that given compound? 7 hydroxyheptane 2 1. So first statement is correct and second is wrong. So here statement first is true and second one is wrong. Therefore first option is correct of that question. So today's next question is, a species having carbon with sextet of electrons and can act as a electrophile is called as. What is the question? The carbon which has 6 electron in outermost shell. So what should be the structure of that compound carbon? One bond has 2 electrons. So one, that is 2 electrons are there. If another one bond, 2 electrons are there. Another one bond, 2 electrons. So here 3 bonds means 6 electrons are there. That is first condition is satisfied. And then it should be electrophile. Then if it is carbanion, then how 8 electron will be there. So carbanion should not be there. So if carbocation is there, then it will be act as a electrophile, because this is will be the electron deficient species. So this is the correct answer. Here another option is that carbanion, carbon free radical. If 3 bonds there and 1 radical is there, then this is the 7 electron species. Suppose 2 bonds are there, 2 bonds are there, this is 5 electron species. So for free radical there is no possibility with 6 electron. So therefore carbocation is the only species that which is electrophile, which contain 6 electron. So here the correct option is carbocation with option C. Here the C option is correct of that question. So the next question is match the list 1 with list 2. In the list 1 there are four four numbers are given. First one is glucose with NaHCO3 heat. Second one is glucose HNO3. Third one is glucose HI and heat. Fourth one is glucose in bromine water. And list 2 is gluconic acid. B is no reaction. C is N-hexane. D is saccharic acid. If you have already studied about the glucose, that is this comes from the biomolecules, then you can solve this you can solve easily this question. So in glucose, what is the structure of glucose? Glucose has one CHO group, OH, on the third carbon atom. OH is at left position, and fourth OH, and here CH2OH. Here in glucose there is not so strong acidic H hydrogen H plus, because NaHCO3 is a weak base, so it requires strong acidic hydrogen. Here in glucose there is no strong acidic hydrogen, therefore if we react glucose with NaH3, there is no reaction, so first with B. If we see the next, HNO3 is a strong oxidizing agent. due to of Due to HNO3 is a strong oxidizing agent, this oxidize glucose to saccharic acid. But here what will happen, CHO is also converted to carboxylic acid. OH is remain same, OHHH, 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 and here CH2OH primary alcohol is also converted to carboxylic acid. Only secondary alcohol is remain same. So name of that compound is saccharic acid. If we oxidize by HNO3, if glucose is reacted with hydrogen iodide in presence of it, then what will happen? HI is a strong reducing agent, so it reduces CHO to alcohol group. Strong reducing agent, therefore this reduces total glucose molecule to alkane. What alkane will be formed? 1 2 3 4 5 6 carbons are there, therefore the alkane with 6 carbon, which alkane is there? Hexane, N-hexane, because there is no branched chain, so therefore normal hexane is formed. There is no need of writing structure of N-hexane, I am writing directly N-hexane is there. Now the fourth is glucose on reacting with bromine water, Br2 water. So here bromine is a mild oxidizing agent. Since it is a mild oxidizing agent, what will happen if we react glucose with bromine water? Since this is a mild oxidizing agent, this oxidize only CHO group, aldehyde group to carboxylic acid, not CH2OH group. So therefore this will be converted to COH group only. Another structure is same. So what is the name of that compound? Gluconic acid. So it gives gluconic acid. So what will be the answer? Glucose on NaOH3O3, no reaction. Glucose on reacted with HNO3, saccharic acid. Glucose on reaction with HI, N-hexane. Glucose on reacting with Br water, gluconic acid. This is the answer, and here the correct option is third. In third option, this pair is given, so therefore third option of that question is correct. So now the next question. The question is, given below are two statements. One is labeled as assertion and the other is labeled as reason R. So here a statement, that is reason is given, that assertion is given, that sorry, assertion is pK value of phenol is 10, and that of ethanol pK value of ethanol is 15.9, and the reason is, that is second statement is, ethanol is a stronger acid than phenol. Ethanol is stronger acid than phenol. So if you not actually know the data of pK value of phenol and ethylene, then you also can solve this question. How? I'm telling that now. Among these, phenol and ethanol, which is the strongest acid? How we can say the given compound is a stronger acid? If suppose phenol is there, and here CH3 CH2 or ethanol is there, if the conjugate base of that given species is more stable, then it is the more stronger acid. So if leaves H plus, then phenoxide ion is formed, and this one is involved in resonance in benzene ring. So this phenoxide ion, that is the conjugate base of phenol, is very much stable due to resonance, so this will be the more acidic. But here, if you remove H plus, CH3 CH2 O minus, here is no resonance, but it is destabilized by plus I effect of that group. So therefore this is very less acidic than phenol. So according to this, we can say that reason is wrong. But what about A? If you know what the Ka and pK value of acid, if given compound is more acidic, then it has a high Ka value. If this is less acidic, then it has less Ka value. And if higher the acidic, more is the Ka value, then pK value is less. And if least acidic, less Ka value, then it has pK value is higher. That is, the pK value is inversely proportional to the acidity of a given compound. So from that we can easily say that phenol is more acidic, therefore this it should have less pK value. 10 is less than 15.9, so therefore 10 is correct for 10 is correct pK value for phenol, and 15.9 is correct for ethanol. So here first statement is correct, that is assertion is correct. So here option is A is true but R is false. So here first option is correct of that question. So now the next question is, so this question comes from analytical organic chemistry. So in the here the question is, match list one with list 2. So here first in list 1, first is distillation, second one is fractional distillation, third one is steam distillation, and fourth one is distillation under reduced pressure. Here in list 2, A is separation of glycerol from spent lye. Second one is aniline water mixture. Third one is separation of crude oil and fraction. Fourth one is chloroform and aniline. So I am writing here direct answer of that question. Here chloroform aniline can be separated by distillation. Second one is aniline water can be separated by steam distillation. Third one is glycerol from spent lye. Glycerol from spent lye is separated by distillation under reduced pressure. reduced pressure. And fourth one is crude oil fraction can be separated by fractional distillation. Fractional distillation. If you have studied about this, then you can only solve this question, otherwise you can't solve this question. Therefore you should have to study the analytical organic chemistry, because some questions are also comes from analytical organic chemistry. So now the today's next question is, the question is the total number of hydrogen atom in the product A and product B is. Here one reaction is given, that CH3CH2Br is reacted with sodium hydroxide. Reaction A is in presence of C2H5OH alcohol, and second one is in presence of water. That is, here ethanol is a solvent, here water is a solvent, here product A, product B. First, to solve this question, find out what is the product A and product B. If we see here, same question is asked here, same question means the question of same concept is also today's first question is. If you see first question of today's part, that was also depend on the same concept, that is NaOH. There in first question KOH is base used, as a base is used, here NaOH is used. If NaOH in presence of ethanol, that is alcoholic sodium hydroxide. In first question alcoholic KOH, what was the product was formed there? Elimination was there. Here also in alcoholic NaOH elimination will be there, and elimination of proton from beta hydrogen and bromine from alpha hydrogen is occurs. So what will be the product? CH2 double bond CH2, and water in presence of water, that is called as aqueous NaOH. In first question aqueous QH, in presence of aqueous QH substitution, nucleophilic substitution is occurs. Here also same aqueous NaOH, here bromine is replaced by OH minus, therefore CH2OH. So here product A is this, product B is this, and the question is that the total number of hydrogen atom in product A and product B is. How many number of proton hydrogens are there? 2 to 4, 3, 7 to 9, and 1 10. So here for answer is 10. This is the numerical answer type question. You have to write directly what is the answer. So here the answer is 10. So now the today's next question is, number of alkanes obtained on electrolysis of mixture of sodium acetate and sodium propionate. So this question also comes from analytical organic chemistry. I hope you have already studied about coal-based electrolysis, coal-based electrolysis. If you have not studied, then study about coal-based electrolysis, then you can well understand that question, solution of that question. So here in the electrolysis, anode is positively charged, therefore here oxidation at anode is happens and the negative species is attracted towards the anode. So here for first species is CH3COONA, and second one is C2H5COONA. So if you take first electrolyte sodium acetate, negative part is that negative ion is what? Acetate ion. Here oxidation is happens, that is loss of electron. Negative charge means 2 electrons are there, so out of this 1 electron is removed. What will form? Free radical will be formed. So after that what will happen? Decarboxylation occurs. So how? By by homolytic cleavage of that carbon and that bond between that carbon and that is homolytic cleavage of that bond. Homolytic cleavage means what? This bond has two electron. One electron goes to that carbon, one electron goes to that carbon. And what will form? One radical is that and another is C double bond O radical. And these two adjacent radical form bond and evolves CO2 as a gas. And CH3 radical is formed here. Here in the another electrolyte is this C2H5O. Anion is C2H5 C double bond O O minus. By oxidation, loss of electron, what will form? C2H5 C double bond O radical will be formed. Same here, homolytic cleavage happens. CH3 CH2 radical is formed and CO2 gas is evolved. So here what will happen? The question is that how many number of alkene will be formed in that reaction. That is electrolysis. What will form? First, this CH3 will combine with same radical, that is CH3 plus CH3 gives CH3 single bond CH3, that is ethane. Again, this radical combine with cell same radical, what will form? CH3 CH2 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 CH3, and this CH3 radical will combine with that C2H5 radical, what will be formed? Plus CH3 CH2 radical, therefore CH3 CH2 CH3. Then therefore how many numbers of alkene are formed? Three types of ethane, propane, butane. That is here, this is also numerical type answer, therefore here answer of that question is 3. So now the next question is, this question is really miscellaneous googly question. So this is the last question of this part. This question is googly question. So question is, there is the possibility of wrong answer, that is you think you made a right answer but this will be the wrong answer. How? First I will write the question. Here CHOOH is there, reacted with Grignard reagent, one equivalent is used, and second one is aqueous NH4Cl. So first Google is that you will be at a nucleophilic attack of that minus pH minus on carbonyl carbon, electrophilic carbonyl carbon, and nucleophilic addition reaction will be carried. But this is the wrong, because if Grignard reagent is there, then the first preference is that firstly acid base reaction will be happen. If you see here, hydroxy group is there and this H plus is more highly acidic, because phenoxide ion of that is well stabilized by benzene ring, as well as electron withdrawing group is at para position, therefore this H is very acidic. So therefore first acid base reaction will be happen. So what will be the byproduct will be formed? This pH, and here H is attached, plus another one is, since here salt is formed, that CHO is remain same, O minus Mg plus Br, and after this reacting with aqueous NH4Cl, what will be formed? CHO and here OH. Basic hydrolysis, that is MgBr salt will be hydrolyzed to phenol, phenoxy group. So this is the same as the reactant, so we can't say to this product because this is the reactant. So here the major product is this is the another googly of that question. This is the major product, this is the reactant, this is not a product, and this is we can say intermediate, this is not able, after hydrolysis this will form that. So this is the reactant. So here the product is that, not this. So the question is the number of hydroxy group present in the product P. If you see, you can write easily, write without any doubt, one hydroxy group is there, but this is not a product, this is a reactant, and major product is this benzene, and in benzene there is no hydroxy group. So correct answer of that question is zero hydroxy groups are there. This is the numerical type answer, numerical answer type question. So this is the most important question, so be careful about that type of question, otherwise you will make wrong answer. So I hope guys you are understanding well that PYQ series, and now I am stopping here. This is enough for today. Next part will be continued in the next part, next video. Thank you so much.